Alright, so I'm going to explain how to do the transformations of sine and cosine. But before that, let me just quickly go to Desmos.com and kind of remind you, like in this assignment, what you're going to be doing is you're going to be mostly transforming, let's see, the regular cosine graph, which looks like this. It's a wave. It starts at 0, 1, ends at 2 pi. And if you could see, we could keep going around the unit circle and we kind of finish up creating a wave here that goes on to infinity. But that's how the cosine function looks like, and we're going to try to transform this function, as in stretch it, compress it, things like that. So in order for us to do that, what I have for you is kind of like a bit of a review of a basic kind of matching. Like, for example, these right here are transformations of a regular parabola function, y equals x squared. Now, if you need a bit of a reminder of the parabola, like, you're free to, like, go on to Desmos and just graph that up. If you don't need that reminder, that's cool. So we're transforming this function in our example so that you should be able to kind of have like a bit of an entry point to do the cosine one. Just reviewing with a basic parabola right now. So this is my parabola function. 1 squared gives you 1. 2 squared will give me 4. And we also have like the same symmetrical pattern here on the other side, right? So we should at least be able to at least first graph what the parent function is. So the basic y equals x squared graph. Now this one looks like the thing I just saw, like the thing I just graphed. But the only issue is that at 1, it doesn't look like it hits 1. It looks like it hits like 2 point something. So I don't think it's A for the first graph. Now this one here, it's kind of like shifted below the x-axis, whereas on my Desmos graph, it was not below here. It was kind of touching the x-axis, so it can't be C, can't be E. This one shifted kind of to the right-hand side. This one again is below the x-axis. It can't be that one. So I'm left off with, it looks like 1 is B. Now let's verify that. So when x equals 1, I should get 1. Yeah. When x equals 2, 2 squared gives me 4. Yes. So it looks like for number 1, you match it up to B. So that's going to be B for number 1. And again, I'm doing this basic example with you so that you could try to apply how to transform a cosine function on your own. Now, I am giving you another tool, by the way, to match the rest of these functions. The virtual calendar, it says here's a transformations guide. So you want to also use this guide. It's a bit of a review for you. For example, if you put a negative in front of the function, it flips it like so. If the x is negative, that's inside the parentheses, it reflects over the y-axis. Moving up and down the function, that's when you do plus k or plus 2, whatever number you want it to be. You can shift it up and down. If it's a plus k and it's inside the parentheses, that's the horizontal shift. For this one, remember, if it's plus, it actually shifts to the left, see? And if it's minus, it actually shifts to the right, like so. So this is all like things you could review. And then down here talks a little bit about stretches and compressions. For example, if you multiply by 2, that means the y value gets stretched by a unit of 2 by multiplying by 2. So instead, for example, this one right here, if it's at 2, 2 times 2 gives me 4. So it got stretched by a multiple of 2. This red function right here, that's if you multiply it by 0.5, it means it would get shrunken, right? Because it's about half of the original height, 0.5. And then there's more about horizontal stretches. But here's the overall rules guide. I'm mostly going to be using this, to be quite honest. Look at that, y'all. There's a rabbit. That's hecka cool. Anyway, so again, if there's a negative that's outside of the function, that's reflection over the x-axis. Negative is inside the parentheses. Reflection over the y-axis. If it's a plus k, and k is like a number, that's shifted upward by k units. If it's minus k, whatever k is, shift down. plus k inside the parentheses, that's going to be left horizontal by certain units, minus k inside the parentheses is going to be shifted to the right horizontally, multiply by k, either it stretches it if it's a number greater than 1, or it shrinks it if it's between 0 and 1. And if the k is inside the parentheses, it does a shrinkage if k is greater than 1, or it stretches horizontally if the k is between 0 and 1. So again, this is your guide. You want to use this. So let's just try to match it up. The remaining stuff here. So let's see. I'm going to try to kind of have this right next to each other so I could see it. There we go. Okay, so the next one I want to try to match up is 3x squared. So there's a 3 in front of my original function. So it looks like I'm looking at this rule. So 3 is my k. Because 3 is greater than 1, I know that's a stretch. That means it's going to be kind of an elongated parabola, or kind of a parabola that looks skinnier. So I know this one looks skinnier than the original b. This one does not look skinnier. I know E looks also skinnier, and so does D. Now, because there's no, for example, there's no like inside parentheses shift going on with this one, I know it's not E because this one got shifted to the right, so it's not E. So I'm kind of getting rid of that. I also know it's not D because D is kind of below the x-axis as if it got moved down a certain amount, so it's not D. So then it looks like it must be this one right here. It looks like this one got stretched by a multiple of 3. For example, when x is 1, you get 3, which looks to be about, yeah. So I believe number 2 should get matched up with A. So this one's A, the first one's B. Let's keep going. Okay, so for number 3, we have an inside the parentheses minus 1, and it's also a stretch by 3. So we have two things happening. So I'm going to just look for the one that's shifted 1 unit to the right. Remember, when it's inside the parentheses, a minus 1, it's actually shifting 1 unit to the right. And the only one that does a sideways shift here, y'all, is E. It's skinny, so it's got multiplied by 3, and it got shifted by 1 unit to the right. So for number 3, the match is going to be E. So number 3 gets matched with E. Take a look. I'm just using this guide right here. All right, let's keep going. Number 4, the graph is going to be multiplied by 3, so it's a thin parabola, and it's moved down by 1 unit. Okay, so we have to look for a skinny parabola that's moved down by 1 unit. So my last two remaining choices I have is D and C. Now, D looks skinnier than C, and if we take a look, I'm hoping that's 1 unit. It has to be because that's all we have left. So this is -4, that must be -2, so this is -1. So yeah, this is a skinny graph, and it's moved down by 1 unit. So number 4 should be D. That means my remaining function, number 5, should be C. It's moved down by 1 unit, but it's still keeping the original wideness as the original function, which is shown here as option B. Because remember, B matched up with the parent function. So number 5 is C, and it looks like we matched all these up. So number 1 was B, number 2 was A, number 3 was E, number 4 was D, and then number 5 was C. So that's how we matched it up, and remember I used that toolkit. Now, what your job is going to be, let me go ahead and minimize this, is you're going to try to use these transformations of functions and apply it to cosine functions. So this right here was the video, and you're using the transformation guides. Now, your assignment, and this is the thing that will get recorded, is you're going to go to the Desmos sort. So you're going to see something like this. If you're logged into your Gmail, right, it should say welcome back and then your name, because you've been on Desmos before. It's going to have the code. You're going to join. What you're going to see, and you could put yep, continue, is you're going to see a card sort that you're now going to match up, but now you're going to be matching up cosine functions. So you have a bunch of cards, and you're going to match it up with its cards here. Once you're done matching up these cards based on what you think should happen as cosine is transforming itself, you're going to, go back here. You could go once you're done matching up all these cards, this next right here is going to like turn green. You could click next and that should get you to finish up the activity. Again, if you're logged into Gmail, it should show me who has completed it and who has not. So for example, like if we want to try to find where the original cosine function is at, you could also use Desmos to help you out, quite honestly. But I definitely recommend you to use what you know about transformations by looking here at this guide. For example, we know cosine starts at 1 up here on the y-axis and ends at 1 at 2 pi. So for example, let me match up that one for you. And I think, so this one looks similar to that. See, it starts at some high point and then at 2 pi ends. The only issue is that this cosine graph is shifted up from the x-axis, so this can't be with this. I have to look for one that's on the, like this one here. It's on the x-axis, starts at 1, goes down, hits 1 again at 2 pi. So I kind of found the parent function right here. There's my match. Now you're going to, again, try to look at the transformations. Whoops. And what you know about transformations to match up the rest of the cards. And then feel free if you want to take a picture of one, if you're uncertain of one, text me on Remind. I'm happy to help. But that's pretty much the assignment today. I hope y'all have fun.